Now we'll look at limits. And I think it'll be easy to just look at our three basic points. So we would have 1/3, -1, 1, 0, and 3, 1, log base 3. As x goes to 0 from the positive side, so as x is getting smaller, 3, 1, 1/3 going this way, what's happening with the y values? They're going down, so we're going to -infinity. Here we have base 1/2, so our 3 points would be 2, -1, 1, 0, and 1/2, 1. We want x going to infinity, so x getting larger goes in this direction. What's happening to the y values? They're getting smaller, so we're going to -infinity. Here we have base e, so I'll have the points 1/e, -1, 1, 0, and e, 1. As x is going to infinity, so as x is going larger, goes this way. What's happening to the y values? They're getting larger also. We go to infinity. And this is base 10, so our points would be 1/10, 1/10, -1, 1, 0, and 10, 1. As x is going to 0 from the positive side, so going this direction, getting smaller, what's happening to the y values? They're also getting smaller, so this also goes to negative, and the limit goes to -infinity. Now we want to find inverse functions, so we'll use that same method of switching the y and the x that we've used before. So right now we have y equals log base 10 of x plus 4. So x equals log base 10 of y plus 4. To be able to get this y out, we're going to have to change this to exponential form. So we will have 10 to the x equals y plus 4. Now I can get y equals 10 to the x minus 4, and putting that in inverse notation, f inverse of x is now 10 to the x minus 4. And we expected our inverse function of a log to be an exponential function. Let's do it the other way around and start with an exponential function and change it to a log function. We'll start by putting in the y equals 2 to the 3x plus 1 minus 6. Switching x and y's, x equals 2 to the 3y plus 1 minus 6. Now, before I can change this to log form, I need to get the base with the power by itself. So I have to add the 6 to both sides. So I get x plus 6 equals 2 to the 3y plus 1. Now that I've got my base raised to the power by itself, I can change this to log form. The exponent is 3y plus 1 equals the log base 2 of x plus 6. Moving the 1, I'll get 3y equals log base 2 of x plus 6 minus 1. I had to subtract from both sides. Now I need to divide by 3. So y can equal log base 2 of x plus 6 minus 1 all over 3. And of course, that is f inverse of x is log base 2 of x plus 6 minus 1 all over 3. And this will be my inverse function. We want to solve logarithmic equations, and sometimes to solve them we need to change them to exponential form. So right now we have the base is x and the exponent is -2. That equals 16/9. Let's take the reciprocals of both of these so we can make this positive. So x squared equals 9/16. So x would equal plus or minus 3/4. However, since our bases can only be positive for logarithms, x will equal 3/4. We want to find the exact solution. We have the base is 16, the exponent is 3/4, and that equals x. So all we have to do is take this. So x equals the 4th root of 16 cubed. Well, the 4th root of 16 is 2, and 2 cubed is 8. We have our solution. Let's get this so we have 2 to the x, and then we can change it to logarithmic form. So 2 to the x, we'll take the reciprocal of both of these, equals 1/5. Now I'll take the log base 2 of 1/5 equals x. And I've actually solved my equation. You can see I have x equals log base 2 of 1/5. And this is the exact solution. We have log base 4 of x equals 1/3. So that means in exponential form, x equals 4 to the 1/3, or the 3rd root of 4. And this is my exact solution. If I grab my calculator and calculate the cube root of 4, I'm going to get a decimal approximation. And so that is just an approximation. This is an exact solution. This one, we want an approximate solution. So we'll go about solving it the same way. We have exponential, so we want that on one side by itself. So 10 to the x equals 8. Now we'll put this in log form, and that will give me x equaling the log base 10 of 8. Now I can grab my calculator since it's base 10, and I can put in log of 8 and find out that it is 0.9031 to 4 decimal places. And this becomes my solution.